What if everything you know about death is wrong? What if dying isn't the end, but a passage? Scientists have long debated what happens in that final moment, yet no one dares to speak aloud the most obvious explanation. Black holes don't destroy, they transport, and the nearest one is only a few thousand light years away. It's already there, already waiting. There's only one question left: where? This isn't science fiction. It's not a conspiracy theory. It's an official hypothesis, developed by the world's leading physics institutes. And if it's correct, black holes aren't a dead end. They're an entrance. An entrance to what? To another universe, another time, a dimension our physics can't yet describe. In this video, we'll explore what really happens inside a black hole, why scientists seriously consider them as possible space-time tunnels, and, most disturbingly, where the nearest one is right now. Let's start with the basics. Imagine you take a massive star, tens of times heavier than our sun, and compress it to the size of a city, or smaller. All that mass, all that gravity, concentrated in a single point. The gravitational pull becomes so strong, it literally bends space itself. Like a bowling ball placed on a trampoline, except the trampoline is the fabric of our universe. Around every black hole lies a boundary, the event horizon, the point of no return. Once you cross it, there's no escape. Not because there's a way back you can't find, but because back simply stops existing. The laws of space inside that boundary are different. There's only one direction left, inward. But here's what no one really knows. What happens beyond that boundary? And this is where things get truly interesting. In 1935, Albert Einstein and physicist Nathan Rosen discovered something strange. Their equations, the very ones describing gravity, allowed for a peculiar structure, a tunnel connecting 2 points in space-time, or even 2 different universes. Today, we call it a wormhole. And here's the astonishing part. Mathematically, a black hole and a wormhole look almost identical. The equations don't forbid such a scenario, meaning every black hole could, in theory, be an entrance to one of these tunnels. But where does it lead? That's where the story takes a strange turn. If a black hole has an entrance, it must also have an exit. In physics, that exit is known as a white hole. A white hole is the mirror opposite of a black one. Instead of consuming, it ejects mass, energy, matter from somewhere else in space. No white hole has ever been observed, yet our equations, the same ones that predicted black holes and gravitational waves, suggest they exist. But there's a problem. Classical wormholes are unstable. They collapse faster than light could ever pass through. To keep a tunnel open, it would take something called exotic matter, matter with negative energy. We don't know if it exists. At least, we didn't until now. In 2013, 2 physicists, Juan Maldacena and Leonard Susskind, published a paper that changed everything we thought we knew about black holes. They discovered a link between 2 completely different areas of physics: quantum entanglement, the phenomenon where 2 particles remain connected across any distance, and the geometry of space-time itself. Their conclusion was shocking. Quantum entanglement is a wormhole. What we once saw as a purely mathematical connection between particles might in fact be a physical tunnel through space, which leads to a remarkable idea. Wormholes exist, always have, right now, at the quantum scale, between every pair of entangled particles in the universe. They're too small for anything to pass through, but they're real. And if entanglement is a tunnel, what happens if we learn how to control it? In theory, it could allow us to create a stable wormhole, not science fiction, but a genuine passage through space-time. In 2022, a paper published in Nature by a Caltech research group took the first step. They ran an experiment on a quantum computer that simulated information teleportation through a wormhole. Not a real one, a quantum simulation. But the results matched the predictions. The math worked. The system behaved exactly as the theory said it would. We're on the right track. And now comes the most uncomfortable question. If black holes are portals, where do they actually lead? Physicists disagree, but there are three main possibilities. First, to another point within our own universe, perhaps billions of light years away, or even into the distant past. Second, to a parallel universe, one of the countless worlds predicted by the many worlds interpretation of quantum mechanics. Not metaphysics, a legitimate physical hypothesis. Third, the most unsettling one, a black hole could lead to a child universe, one it creates itself. This was proposed by cosmologist Lee Smolin. Each black hole gives birth to a new universe with slightly altered physical laws, a kind of cosmic evolution. And if that's true, our universe too was born from a black hole in another universe. Now let's talk about the nearest black hole. It's called Gaia BH1. The distance is about 1,500 light years away. On a cosmic scale, practically next door. Gaia BH1 is the closest known black hole to Earth, with estimates placing it at roughly 1,560 light years away. And it is dormant, rather than actively feeding on matter. It's not active. It isn't consuming anything. It's just hanging there in space. But there's something even more unsettling. At the center of our galaxy lies a supermassive black hole, Sagittarius A star. Its mass is about 4 million solar masses, and it is roughly 26,000 light years away. The black hole at the center of the Milky Way was directly imaged by the Event Horizon Telescope in 2022. And here's what we've discovered. In 2022, the Event Horizon Telescope first photographed Sagittarius A star. We saw the center of our own galaxy, the object around which everything revolves, including us. If the portal hypothesis is true, then there are gates at the center of our galaxy. But here's where the truly disturbing question appears. What happens to information inside a black hole? It's called the information loss paradox. Quantum mechanics says information is never destroyed. Never. It's a fundamental law of nature. But black hole physics says everything that falls in disappears forever. Those two laws cannot both be true. Stephen Hawking spent his life arguing about this with other physicists. It was one of the greatest scientific conflicts of the 20th century. And shortly before his death, Hawking changed his position. He suggested that information does not disappear. It is stored on the event horizon and then slowly returns to the universe in the form of radiation. This is called Hawking radiation. But here's the problem. That radiation is so weak that no instrument on Earth can detect it directly. We cannot verify what happens inside, and that means everything you just heard may be true, or it may not be. We simply do not know. Think about it from this angle. We are a species that has existed for only a few 100,000 years. We built pyramids, launched satellites, created the internet. And in all that time, we still have not been able to look beyond the event horizon of a single black hole. We know almost everything about them from the outside. But what's inside remains beyond the reach of our knowledge. Physically, forever. Anyone who falls in there will never be able to send information back. We live in a world that has physical limits to knowledge. And there is one thought that haunts many physicists. If every black hole creates a new universe, how many exist right now? In the observable part of our universe alone, there are more than 1 trillion galaxies. In each one, There are hundreds of millions to billions of stars, and a significant number of them end their lives as black holes. Trillions of black holes. Trillions of possible universes, each with its own laws, its own time, perhaps its own forms of life that will never know we exist. And we are just one point in this infinite structure, born from a black hole, living in a universe where there are trillions of them, and having no idea what happens on the other side. Maybe right now, in another universe born from a black hole somewhere in our galaxy, someone is asking the same question, and finding no answer either, because the answer is on the other side of the horizon, and nothing comes back from there.